Hi, it is JIT UA Courses, and welcome to the 6th lesson of the .NET Developer series in which we will cover the most relevant topics to become a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will continue with the internal elements of the class, and now we will cover methods, method parameters, modifiers, and method overloading. We will start with methods. If fields store some values, then methods contain a set of instructions that perform certain actions. A method is actually a named block of code that performs some action. Modifiers and parameters are optional. Previously, we already used at least one method, console.writeLine, which outputs information to the console. Now we will learn how we can create our methods. Definition of the method. Let's define one method. The printHi method is defined here, which outputs a greeting to the console. Method names have the same requirements as property names. The method name is preceded by the returned data type. Here it's a void type, which indicates that it doesn't actually return anything, it just does some action. A list of parameters in parentheses follows the name of the method. But in this case, the parentheses are empty, which means that the method takes no parameters. Following the parameter list in parentheses is a block of code that represents the set of instructions executed by the method. In this case, the printHi method block contains only one instruction that outputs a string to the console. But if we run our code, we won't see any line in the console. Because after defining the method, it still needs to be called to do its job. Calling methods. To use the printHi method, it must be called. To call a method, its name is specified, followed by the values of its parameters in parentheses, if the method accepts parameters. For example, a call to the printHi method would look like this. Since the method takes no parameters, the method name is followed by empty parentheses. Let's combine the definition and the method call. The advantage of methods is that they can be called repeatedly and many times in different parts of the program. For example, you can call printHi twice and it will simply do the same job twice. Method's short definition. If a method defines only one statement as a body, we can shorten the method definition. For example, suppose we have a method like this. We can also shorten it this way. That is, the list of parameters is followed by the arrow operator, followed by the instruction being executed. Returning the result. The method can return the value of any result. Before that, we used methods that return void type. Methods with this type do not return any value. They just perform some actions, but methods can return some value. For this, the return operator is used, followed by the return value. For example, let's define a method that returns a string value. The getHello method has a type string, so it must return a string. Therefore, the return operator is used in the method's body, after which the return string is indicated. Methods that have any type except void must use the return operator to return the value. For example, the following method definition is incorrect. Also, there must be a match between the return type of the method and the value after the return statement. Cannot return int if the string is expected. The results of methods that return values can be assigned to variables or otherwise used in the program. The getHello method returns a string value. Therefore, we can assign this value to any string variable. Or even pass a parameter value to another method. In this call, the getHello method is first called and its result is passed to the message parameter of the print method. After the return statement, you can specify complex expressions or calls to other methods that return a specific result. For example, let's define a method that returns the difference of numbers. The diff method has type int, so it must return a value of type int, an integer. Therefore, the return operator is used in the body of the method, followed by the number to be returned. A short version of the methods with the result. We can also shorten methods that return values. It is the same as the following method. but it could be also shortened with an arrow syntax. Exiting the method. The return operator can not only return a value but also exit the method. Therefore, it should be determined after all instructions. For example, from the point of view of syntax, this method is correct, but its instruction console.writeLine does not make sense. It will never be executed, since before its execution, the return operator will return a value and exit the method. However, we can use the return statement and methods with the void type. In this case, no return value is placed after the return statement, because the method does not return anything. A typical situation is to exit the method depending on the preconditions. Here the printAge method takes age as a parameter. However, in the method body, we first check if the age matches some range, less than 130 and greater than 0. If the age is outside this range, we display a message about an unacceptable age and exit the method using the return operator. After that, the method finishes its work. Method parameters. In the previous section, the sayHi method was defined, which outputs some messages to the console. However, the downside of this method is that it outputs the same message. And it would be nice if we could dynamically determine which message the method will display on the screen. To do so in C# we can use parameters. Parameters allow you to pass some input data to the method. The definition of a parameter consists of two parts. First comes the type of the parameter, and then its name. For example, let's define a print method that receives a message output from the outside. Here, the print method takes one parameter called message and is of type string. To execute a method that has parameters, it is passed its parameter values when called after the method name in parentheses. Here, the string hello work is passed to the message parameter. Values passed to parameters are also called arguments. So the string hello work passed is an argument in this case. Let's define another method that adds two numbers. The diff method has two parameters x and y. Both parameters are of type int. Therefore, when calling this method, we must pass two numbers for these parameters. Inside the method, the sum of the passed numbers is calculated and output to the console. When the diff method is called, the values are passed to the parameters by position. For example, in the call diff, the number 15 is passed to the x parameter, and the number 10 to the y parameter. Parameters can also be used in a shortened version of the method. The values passed to the parameter can represent the values of variables or the result of complex expressions that return some value. If variable values are passed as method parameters, then the variables must be assigned a value. For example, the following program does not compile. Matching parameters and arguments by data type. When passing values to parameters, it is important to consider the type of parameters. There must be a type match between arguments and parameters. In this case, the first parameter of the print method is of type string, so when calling the method, we must pass this parameter a value of type string. The second parameter is an int type, so you must pass it an integer that corresponds to the int type. Data of other types we cannot transfer parameters. For example, the following call to the print method will fail. Optional parameters. By default, when calling a method, you must provide values for all of its parameters. But C# also allows you to use optional parameters. For such parameters, we need to give them default values. It should also be noted that after declaring the first optional parameter, all the following parameters must be optional. Here, the age and city parameters are optional as they are given values. Therefore, when calling the method, we may not pass data to them. Named parameters. In the preceding examples of method calls, values for parameters were passed in the order in which those parameters were declared in the method. That is, arguments were passed to parameters by position. But we can break this order by using named parameters. Parameter modifiers. There are two ways to pass method parameters in C#, by value and by reference. Passing parameters by value. The simplest way to pass parameters is by value. In fact, this is the usual way to pass parameters. When passing arguments by value, the method parameter receives not the variable itself, but its copy and continues to work with this copy regardless of the variable itself. Passing parameters by reference and the ref modifier. To pass the arguments by reference, we add the ref modifier. When using parameters by reference, the method receives the address of the variable in memory. Thus, if the value of the parameter changes in the method, the value of the variable passed in its place also changes. Note that the ref modifier is specified both before the parameter when declaring a method and when calling a method before the argument is passed to the parameter. Output parameters. Modifier out. Above we used input parameters. But the parameters can also return values. To make an output parameter, put the out modifier in front of it. Here, the result is returned not through the return statement, but through the output parameter result. Also, note that methods that use such parameters must obligatorily assign a value to them. We need such parameters that we can return not only one value from the method but several. Input parameters. Modifier in. In addition to output parameters with the out modifier, the method can use input parameters with the in modifier. The in modifier indicates that this parameter will be passed to the method by reference, but its parameter value cannot be changed inside the method. For example, let's take the following method. Method overloading. Sometimes it is necessary to create the same method but with a different set of parameters. Depending on the available parameters, call a certain version of the method. This possibility is called method overloading. In C#, we can create multiple methods in a class with the same name but different signatures. What is a signature? The signature consists of the following aspects. The name of the method. Number of parameters. Parameter types. Order of parameters. Parameter modifiers. And method overloading is when the methods have different signatures in which only the method name matches. That is, the methods should differ by number of parameters, type of parameters, order of parameters, parameter modifiers. For example, let's look at this calculator class. 4 different versions of the add method are presented here, that is, 4 overloads of this method are defined. The first 3 versions of the method differ in the number of parameters. The 4th version coincides with the first in the number of parameters but differs in type. At the same time, it is enough that at least one parameter differs in type. Therefore, it is also a valid load of the add method. After defining the overloaded versions, we can use them in the program. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell not to miss the following videos in the series. Feel free to leave a comment and like this video. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.